Hi my dear students. So in the last class we were discussing about mainly the mass percentage, mass fraction, the volume fraction, the volume percentage, okay, and we were discussing mass by volume. Okay, so in this class today we will be discussing about the problems on that. Okay, so first we will go through a question. Okay, I hope you could read the question. Find the percentage by mass and mass fraction of aspirin in the solution prepared by dissolving 3.65 gram of aspirin in 25.08 gram of water. Okay, so in this question they are asking you to find out mass fraction and mass percentage. Now what is the formula that you remember for mass fraction? I hope you remember mass fraction is nothing but mass of the solute divided by mass of the solution. Please remember it is mass of the solution. Okay, how you are getting a solution? It is by mixing solute with the solvent. Okay. Now here they told mass of the solution is nothing but mass of the solute plus mass of the solvent. Now we know that mass of the solute is aspirin and its mass is 3.65 gram, that I have substituted here. Okay, and what is the solvent? Water, and its mass is 25.08 gram. So on mixing 3.65 gram of solute with 25.08 gram of water, you are getting the mass of the solution. Please remember this always. Solution is nothing but a mixture of solute plus solvent. Okay, so I know that now the mass of the solution is nothing but 28.73 gram. Now to find the mass fraction, I know that it is mass of the solute divided by mass of the solution. So mass of the solute, we know it is aspirin and its weight is 3.65 gram, and mass of the solution we have calculated here, that is 28.73 gram. Okay, so on dividing this by this we will get 0.127. okay, now you have calculated mass fraction. Okay, so how to get the mass percentage? We know that mass fraction, when it is multiplied by 100, we will get mass percentage. So mass fraction multiplied by 100, so 0.127 into 100 will give you 12.7 percentage. So that is the mass percentage, and another one is mass fraction we have calculated. So always remember, here also you know this mass fraction is mass of the solute by mass of the solution, or mass percentage is mass of the solute by mass of the solution into 100. It has no dependency with volume, so I can say that mass fraction or mass percentage is independent of temperature. Very important to remember. Okay, so I hope you understood how to do this. So always remember this. Sometimes they will give, instead of the weight of the solvent, they will give the weight of the solution directly, so you don't want to find the mass of the solution then. So here in this case they have separately given the mass of the solvent, so that's the reason why we are adding solvent weight with the solute to get the mass of the solution. Okay, I hope you understood. We will go to the next question. Okay, so I hope you could read the next question. I will just read the question. A solution, it was prepared by adding 125 centimeter cubed of isopropyl alcohol to water until the volume of the solution was 175 centimeter cubed. Find the volume fraction and volume percentage of isopropyl alcohol in the solution. Okay, so in this question what we need to understand here is the solute is isopropyl alcohol, which is liquid in nature. Okay, and the amount of that solute is 125 centimeter cubed. Okay, so also remember 1 centimeter cubed is nothing but 1 cc, 1 centimeter cube, that is called cc, centimeter cube, and which is equal to 1 ml. Okay, so you can easily replace centimeter cubed with ml if you need. Okay, now until so into this isopropyl alcohol is added to water until both mixture becomes 175 centimeter cubed. That means the volume of the solution is what? 175 centimeter cubed. So in this question they have not given separately the volume of the solvent, so you have added 125 centimeter cubed of isopropyl alcohol to water, so that both it becomes 175 centimeter cubed. Okay, now find the volume fraction and volume percentage of isopropyl alcohol in the solution. Now we know that volume of the solute is nothing but isopropyl alcohol, which is 125 centimeter cubed, and we know that volume of the solution, so both isopropyl alcohol and water, The mixture is 175 centimeter cubed. Now we know that volume fraction is nothing but volume of the solute to the volume of the solution. So 125 divided by 175. Since it is a fraction, it is irrespective. If you put 1 centimeter cubed or ml, it will get cancelled off. Numerator and denominator, it will get cancelled off. So you will get a value 0.714. Okay, now to find the volume percentage, what you need to do? Volume fraction multiplied by 100. So when you multiply by 100, it will become 71.4%. Okay, I hope you understood this. Now since it depends upon the volume, I can say that volume fraction or volume percentage is depending on temperature. Okay, so I hope you understood. We will go to the next concept. So the next concept what we are going to discuss, or the next unit what we are going to discuss, is formality. Okay, so I know now we have learned about molarity, molality, normality, mass fraction, volume fraction, mass by volume, then mole fraction we have learned. So the next one is formality. Okay, so formality, what is formality? So first of all we need to know it is another unit, we can take it like that. And please remember, it is same as molarity. Only difference is, what is molarity? The number of moles divided by volume of the solution in liters. Hope you remember. So in that, number of moles is defined as weight in gram of the solute divided by molecular mass of the solute. Now we say that this molecular mass is a term, common term. So if the compound or if the solute is ionic in nature, for example sodium chloride, KCl, something like that, in that case instead of molecular mass we use the term formula mass. Okay, what is that? Formula mass. In that case we say instead of molarity we use the term formality. Okay, so here if you see, so formality is defined as the number of formula mass in grams present per liter of the solution. Okay, that means formality is equal to mass of the solute in gram, same as number of moles, weight in gram of the solute. Okay, divided by, instead of molecular mass of the solute we used to say formula mass of the solute. So how to find the formula mass? Same as molecular mass. How to find the mass of sodium chloride? Sodium mass is 23 and chlorine mass is 35.5. You add it, you will get formula mass. So since it is an ionic compound we use the term formula mass. So since formula mass is coming here, instead of molarity we say it is formality. Okay, divided by volume of the solution in liters. Since it also depends upon the volume of the what? Solution. You can say it is volume term. We can say that formality is also a term that depends upon what? Temperature. So I hope you understood. This is not commonly used, but as a definition you need to learn it. So I can say one formal is what? One formal, one F. How I can get, if I want to get 1F, I will put volume of the solution as 1 liter and mass of the solute, and this value should also be, when you divide you should get 1. In that case we say it is 1 formal. Okay, so I hope you understood this concept of formality. Next we will discuss the next concept, that is parts per million. So the next thing what we are going to discuss is called parts per million, or it is called ppm. Okay, so where it is used, that is what we need to know. ppm is actually a unit that is used for the solute is in very less quantity compared to what? The whole solvent. Okay, for example the air pollutants. Okay, nowadays we know that pollutants are increasing, but compared to the whole air of the atmosphere we can say that the pollutants are very less, correct? And we also used to see the hardness of water, because we know the bicarbonates and carbonates which will give the hardness, that is also present in very small quantities in water, that will give the hardness. So to express their concentration we use the term parts per million. And we know that when you mix, or when you have this air pollutant with air, we say again it is a solution, correct? Both are gases. Okay, it's also a mixture which is a solution, nothing but solute is pollutant and the solvent is the air. Okay, now so in those cases we use the term parts per million. So that's why the million term is coming. So with parts in millions, so we say among the millions how many parts are there, that is the exact meaning. Okay, now if you see here, parts per million can be expressed in three different ways. If you express by mass, that means solute will be in mass, also the solution will also be in mass. That is mass of the solute by mass of the solution into 10 power 6, very important, million. Okay, 1 million. And parts per million by volume. So if you say by volume, it will become volume of the solute by volume of the solution into 10 power 6. Now another way we can express, that is called mass by volume. There how it will become, it will be mass of the solute divided by volume of the solution. In both these cases, both numerator and denominator are mass, so the unit is of no importance. So here also volume, denominator is also volume, so no importance. But in the last one you can see mass of the solute and volume is coming. So you can say mass of the solute normally we use in grams, and volume of the solution we express it in ml. So multiplied by 10 power 6 you will get parts per million. So I hope you understood this also. So next we will try to do one question based on this. Okay. Hi, so now we will discuss a question regarding parts per million. Okay, so read the question. Here you could see 100 gram aqueous solution of calcium carbonate contains 10 gram of calcium carbonate. So aqueous solution of calcium carbonate means calcium carbonate in water. Okay, so how much is that solution? 1000 gram. And in that, how much amount of calcium carbonate is present inside that? 10 gram. Okay, now the question is concentration of the solution is. So in the question they have not mentioned any ppm or anything, but in the options you could see the options are given in ppm. So the option A is 10 ppm, option B 100 ppm, option C 1000, and option D 10,000 ppm. Okay, so here how you know that? Now we know that in ppm you need to find the answer. Now ppm of the substance is, now which formula we need to apply? Here given is a mass, solution is given in mass, the solute is also given in mass. So I know that mass of the solute by mass of the solution is the formula I need to apply, multiplied by 10 power 6. So here mass of the solute is how much? 10 gram. So I substituted 10 in the numerator. Then mass of the solution is 1000 gram. So that I substituted. Now if I calculate 10 power 6 into 10 is 10 power 7 divided by 10 power 3. So you know that a power m divided by a power n. It is nothing but a power m minus n. So similarly a power m into a power n is nothing but a power m plus n. So similar formula I am using. So I am taking this on the numerator, means 7 minus 3, that is 10 power 4. Or even you can cancel it and get the answer. So I hope you understood. So this is the way you can expect questions. Okay. So next we will discuss the next concept in this one. Okay, the next term, next concept. So right now we have learned about many things. First one was molarity, molality, normality, formality, mole fraction. Then we learned about percentage by mass, percentage by volume, percentage of mass by volume, parts per million. Now the next one is strength of the solution. It is represented by the letter S. Okay, so what is strength of the solution? So strength of the solution is nothing but it is defined as the amount of the solute in grams divided by mass of the solution in liters. That is, we can say mass of the solute in grams divided by volume of the solution in liters. So if you say strength as 1, then we can say it is defined for 1 liter of the solution. Mass of the solute in gram dissolved in 1 liter of a solution is known as its strength. Okay. So now many students have a doubt here. They used to say, sir, then what is the difference between strength of the solution and molarity? So please understand that molarity of the solution has only one difference with this formula. What is that? In molarity, here it is not mass of the solute, their number of moles of the solute divided by volume of the solution in liters. So here what is the difference? In number of moles we know. What is number of moles? Mass of the solute in gram divided by molecular mass. So here we are not taking molecular mass. That means strength of the solution is mass of the solute in gram. that is given solute's weight in gram divided by volume of the solution in liters. Now there are different ways we can represent the strength of the solution. We can represent the strength of the solution in terms of what? Molarity also. So that is what next we are going to see. That is the strength of the solution in terms of molarity. Okay, now we are going to see how you can represent strength of the solution in terms of molarity. That means the relation between strength of the solution and molarity. Okay, for that what you need to do is first to define strength of the solution. So we know that strength of the solution is equal to mass of the solute in gram divided by volume of the solution in liters. I hope all of you know. This is what we have learned now, just now. Now what we are doing, we are cross multiplying it. Okay, so this is multiplied with this one and this is multiplied by 1. Okay, now on cross multiplying we can see strength of the solution into volume of the solution in liters is equal to mass of the solute in gram. Correct. Now what we need to do, divide by molecular mass of the solute. Divide by molecular mass of the solute on LHS and RHS. This is my LHS and this is my RHS. Okay, so on division we will get like strength of the solution, that is represented by the letter S. S into volume of the solution in liters divided by molecular mass of the solute. Okay, on right hand side also I am dividing mass of the solute in gram divided by molecular mass of the solute. So if you see here, from this one what I am trying to do is mass of the solute divided by molecular mass of the solute. So this term as you see here, okay, this represents my what actually? The number of moles of the solute. Okay, here I am retaining the same strength of the solution into volume of the solution divided by molecular mass of the solute. Now you could see I am taking this volume of the solution to the denominator. I am taking to here. Now in the next step you could see strength of the solution divided by molecular mass of the solute is equal to number of moles of the solute divided by volume of the solution in liters. So now you can see here what I have next done. So volume of the solution is coming down. Now you know that number of moles of the solute is present in the numerator and volume of the solution I have taken to the downside. Now we know that this term number of moles of the solute divided by volume of the solution in liters, that is called my molarity. Okay, so this term as such is becoming molarity. Now I am taking this term to the numerator. So when it comes to the numerator I can say molarity multiplied by molecular mass of the solute. So as such we can say that strength of the solution can also be written as molarity into molecular mass of the solute. So first thing, we have now learned two formulas. One is the strength of the solution is, what is that? Mass of the solute in grams divided by volume of the solution in liters. Another formula is strength of the solution is equal to molarity multiplied by molecular mass of the solute. So similarly we can also represent strength of the solution in terms of normality also, that we will see next. Okay. So very simple, if you want to represent strength of a solution in terms of normality, just look at the formula of molarity. So strength of the solution is equal to molarity into molar mass of the solute. So when it comes to normality, what you need to do, instead of molarity you write normality, molar mass, we know number of moles is weight in gram by molecular mass, that's why molar mass is coming. When it comes to normality, we know it is number of gram equivalents. Instead of number of moles, what will come? Number of gram equivalents. In that case, weight in gram divided by equivalent mass. So molar mass instead of molar mass, what will come here? Equivalent mass of the solute. Okay, so I can derive this, but I am giving this as a homework for you. Try to do it. If you are not getting, let me know, I will try to derive it. Okay, so there are 3 formulas we have learned. So I will write the third formula also. So the strength of a solution is equal to mass of the solute in gram divided by volume of the solution in liters. So these 3 are the basic formulas you need to remember. I have seen these questions repeatedly for Neet and everything, but in your CBSE textbook this is not prominently written. So there you might not be seeing this, but very important for the entrance point of view. Okay, so I hope you understood this topic. So next one, what we are going to deal is the concept of dilution. So with that we will end our topic of expressing the concentration of the solution. Okay. So next I am going to explain the concept of dilution. So the concept of dilution is very simple. So what do you mean by the term dilution? Dilution means diluting, right? So something that was very concentrated, you are adding something to make it diluted. Okay. So here if you see, you could see a beaker here. So in this beaker I have a solvent. Let's say this is water. Okay, this is my water, that is a solvent, and I have some solute, and this solute I am saying it is sugar. Okay, it is dissolved anyway. So to make you understand that, I have shown in blue color, otherwise it is a mixed thing. Solute plus solvent is mixed as a solution, because we know that solution is a homogeneous mixture and you cannot see it separately with your naked eyes. I know that. So but for you to identify, just to learn this concept, I am showing like this. Okay, so here if you see 4 solute particles I have shown totally. Okay, now what is dilution? Dilution means addition of more solvent into a solution. So that what will happen here, you could see initially the level of the solution was only up to this, but after the dilution you could see here it has increased up to this much. Okay, now what has happened? So after the dilution, after adding solvent, what are the phenomena that has happened, or what are the things that remains still constant? I can say that amount of solute, if you see, still that 4 solute is only there. That is remaining constant. So if the amount of solute is remaining constant, then I can say the number of moles of the solute remains constant. Why? Because the number of moles is nothing but weight in gram by molecular mass. That does not have any relationship with the solvent. Okay, so that should remain the same. Then what are the other things that is remaining the same? The number of gram equivalents of the solute, because the number of gram equivalents of the solute is nothing but what is that? Now you have learned weight in gram divided by equivalent mass. That also does not have any relationship with the solvent. So I can say after the dilution, the amount of solute remains the same, or the number of moles of solute remains the same, or the number of gram equivalents of the solute remains the same. Okay.